Hi everyone! So in this video I am going to discuss what we all as a class found during the diffusion week in our labs. And as you probably recall, during the diffusion week we all learned about spherification, and we learned about how the processes of random walks and gelation explain the culinary phenomenon that is spherification. And after you had all learned about these processes, you all, or most of you, went into your kitchens and you studied diffusion in various foods that you had at home. And we gave you some different options. So some of you, if you happened to have access to food coloring and eggs, you could measure the diffusion of food coloring in egg white. Or if you had easier access to soy sauce, you could look at the diffusion of soy sauce in egg white. And for those of you who wanted to make ceviche, you could measure how far protons, or the hydrogen ions that are present in lime juice, diffused into fish or shrimp. And so you did this, and then you used the equation of the week, which was L equals the square root of 4dt. And based on your measurements of time and the diffusion distance, you were able to get a diffusion coefficient for all of these things. And then some of you reported your values in a Google Doc, and I'm now going to show you what we all as a class found based on all of your measurements. So I'm now going to switch to a screenshot of a couple of histograms, and we will see what we found. Okay, so here is first a picture of the procedure that those of you who did the egg experiment followed. And I've borrowed this picture from a student, Godvachka, who posted this beautiful picture on the discussion forum, which I have to say was really just one of many, many really beautiful pictures of eggs and ceviche and diagrams and calculations that could be found there. So this is what you did. You boiled eggs for about 20 minutes, and then you scooped out the yolk and you filled the cavity with either soy sauce or food coloring, and then you waited over time and saw how far into the egg white the color diffused. And so here is just another picture using green food coloring or soy sauce. And one student just cut the egg into little squares and found it easier to measure the diffusion that way. And so here you see really very markedly the increase over time. So here is what you found, those of you who measured the diffusion coefficient in soy sauce in egg white. And it looks like as a class, we, or you I should say, seems to think that the diffusion coefficient of soy sauce in egg white is about 1 × 10⁻⁶ centimeters squared per second. And so to put this into perspective, we can compare it to the diffusion constant of calcium in water. And of course, the assumption we're making here is that egg white is mostly water. And so what we're measuring is the colored particles in the soy sauce in water. So the diffusion constant for calcium in water is 8 × 10⁻⁶ centimeters squared per second. So it seems like these diffusion constants are on about the same order of magnitude or so. So this histogram shows us how the diffusion occurred of food coloring in egg white. And it seems like this diffusion was a little bit slower. Overall, most people measured somewhere in the range of 1 to 5 × 10⁻⁷ centimeters squared per second. So the diffusion of food coloring was a little bit slower, about 10 times or so, roughly slower. And we can think about various reasons for why this could be the case. And there could be many reasons for this, but one of the most likely reasons is probably that soy sauce or the colored particles in soy sauce are smaller than the food coloring. And you can, to understand this, you can think back on Nathan Myhrvold's lecture where he mentioned the platform, where a very crowded platform, and you can imagine that if you had a very small creature on a crowded train platform or subway platform, maybe a cat or a mouse, it would very easily be able to scurry along between people's legs and reach the other side of the platform more quickly than a grown-up person would do trying to make his or her way through the crowd. And so this would be the reason that a small particle kind of diffuses its way faster through a material. And other reasons could be different charges on the particle and so on. So also, as some of you pointed out, is that when you think about the food coloring, it really depends on what kind of food coloring you use. And one student did this beautiful experiment showing how the different types of food coloring can diffuse at different rates. And so this is actually egg white that has been boiled in a test tube. And Wave Dave did this experiment, and he just put green coloring on the top and then watched as the yellow particles diffused faster than the blue particles. And so this is obviously another reason why you would get sort of a spread in the histogram up in the food coloring. And of course, some of you then made beautiful dishes. Here's a picture of deviled eggs that also seems to have a little bit of diffusion of soy sauce on it. Lots of gorgeous pictures like this one. Many of you instead decided to look at ceviche and the recipe of ceviche more carefully. And to do this, you put pieces of fish in lime juice for increasing amounts of time. And here is a picture showing this. So this is what looks like tuna fish put in lime juice for 5 minutes, 10, 20, 40, and 60 minutes. And what we were interested in here was to see how the pH of the lime juice affected the fish. And we knew from earlier in the week that as the pH or as the hydrogen ions move into the fish, it's causing a phase transition, and that phase transition we can see because it's affecting the proteins, and it renders this sort of cooked characteristic of the fish or the shrimp. And so by measuring this layer, we could get an estimate for the diffusion distance. And so here is another picture showing the same thing. And here is what we found. So here's the diffusion coefficient of lime juice in fish or shrimp. And just like before, on the x-axis is the diffusion coefficient. And this is a little bit unclear. This is the max here is 1.5 times 10 to the negative 4. So as a class, we more or less agreed that the diffusion coefficient is somewhere on the order of 5 or so, something like that, times 10 to the negative 6 centimeters squared per second. And again, if we compare this to calcium ions, the diffusion of calcium ions in water, which is also a small charged molecule, this is 8 times 10 to the negative 6 centimeters squared per second, or this was the number that we used in the class. And so more or less, it looks like our measurements as a whole are quite similar to that of calcium. And here I'm showing you just some different diffusion coefficients in water of a number of different molecules, some larger ones and some ions over here. And you can study this and see how the different numbers that we got compare to these, but more or less, so this is in the range of 10 times negative 6 centimeters squared per second, and it looks like more or less we're in the same range as we get from this particular source. So many of you then went on to make beautiful ceviche recipes. Here's one, here's shrimp ceviche, another one, and yet another one. And these are just some of the beautiful pictures that could be seen on the discussion forum. So in summary, what we really did as a class, we did a large-scale experiments. And even if we probably did our experiments pretty differently, so for example, many of you noted that it was not entirely easy to see the diffusion into the egg white. There was kind of a blurry diffusion front, and it was kind of up to you to decide exactly where you would measure that distance. And of course, many of you use different kinds of food coloring, even of soy sauce. Some of you saw a difference in different kinds of soy sauce. Many of you probably use different kinds of fish, different cuts of fish, and all of this probably influenced your results. And as a whole, though, it seems like we have all arrived as a group at diffusion constants that are really quite respectable and that seem to correlate with what you would get in the literature of where people have looked at this more carefully.